Hey folks, welcome out there. It is Mathline time. You have tuned in the right place. I'm Ernie Roberts. I am your host for this afternoon's Mathline session. There I am, Ernie Roberts. You got it. And you know what? What we need you to do is become a part of this show today, all right? We are on the air in order to work math problems live together. We want you to call in at 844-686-2378. Join us. Let's work some math problems together on the air. Have a good time in doing so. And, maybe learn a few things and work things out together. It always works out in a nice way when we can work in that regard. Again, that number, 844-686-2378. We want to hear from you. We've got operators waiting to take your call to talk with me. We'll talk live on the air and get a chance to see what we got going on in the math world today, all right? Hope you're having a great day. We are here. We want to even make it greater. Give us a call, all right? And while we're doing that, let's take a look at problem of the day. Little algebra today. It says solve for P in the equation. Oh, remember to check your solution. We always want to do that, right? When we get the answer, we want to make sure it works before we submit it to our teacher or to our friends or whatever. So we've got 5P minus 3 plus 2P. So there's a lot of P's in here. Equaling, on the other side of the equals, we've got 2 times in a parenthesis 21 minus P. So, whoa, sounds a little complicated. Let's work on this thing. All right, let's take a look at it, see what we've got going on. First of all, 2 things we got to figure out. We've got to figure out what's going on with P, and then we got to go back and check and make sure that P value we get is a working answer. Makes both sides of the equation equal. That's the idea. In other words, get a balance here going. So are you ready? Let's find a balance. Let's go for it. First of all, I look and I think and I wonder, where do we go on the left-hand side? I see some P's that need to come together, all right? Now, some of you say, well, there's a P over there on the right, Ernie. Don't worry about that one yet, okay? We'll deal with it in just a second. But right now, let's get these two guys together. Like terms, ready to flow, and I have a 7P and a minus 3. That reduces down to. So that was pretty good. Now, if you're writing these things down at home, there you go. That's your first step. Let's go ahead and let's go ahead and distribute. Why not? Oh, let's put it down like it is. All right, do one thing at a time. I like that too. So also nicely, there we go. Now over here, let's play with the distributive property. Let's take 2 times everything. In other words, it's going to double everything that's inside that parenthesis. That's what the 2 outside is telling me to do. So 2 times 21, that gives me 42. I have a minus that is not going anywhere, my friends. So we're going to minus 2 times that quantity P. On the left-hand side, we haven't done anything this time. There we go. Now, so you're probably wondering, could we have done both of these moves in the same step? Sure, it's no problem. They're not affected. They're really independent of each other. We're going to be using the results here to get over here in just a second. But for right now, that would be fine. Would not be a problem whatsoever. Now, I like moving the P's and getting them together first. Now, I've got a minus 2P over here, and I've got a 7P over here on the left. My friends, whatever you do on this problem, don't add these two. There's an equal separating you. It will not allow you to do it. Or in this case, subtract these two, all right? I was thinking like adding a negative 2P to 7P. 5P is not what we want to end up with here. What we do want to do, however, is to remove this minus 2P by subtraction. So we're going to add. All right, we got a subtraction hanging out there. We're going to add. And if we do it to the, you got it. You're getting with me, aren't you? If you do it to the right side, you got to do it to the left side, the exact same operation. So here we go. Let's add that 2P right over there. And all of a sudden, things begin to look a little bit nicer because our P's are all together. And when I talk to my students in a problem like this is what y'all can do so well. Once you get to this point, it's easy. It's very straightforward. One more thing you got to worry about. What are we going to do with this minus 3? What do we do with the minus 2P over here? We added 2P to both sides. Let's do the same game plan here. We want to move this 3 to where it joins up over here. And in moving a minus 3, we're going to have to add 3. Because see what happens? That gets a 0. Those cancel out. That's the whole idea. And you got 9P equaling to 45. Now, folks, 9P, don't get excited about this. Some of you say, oh, there's a variable. We don't like those. Yes, we do. We're fine. We're fine. We're going to find out what it is. So we're going to divide both sides by 9. And that's going to leave us with P equaling to 5. Now, question is, did we make any mistakes? Did we get it right? We got anything we need to fix? And how do we know that? Let's go back to the beginning equation. All right, let's go back to 5p. We're going to put it right down here. Minus your 3 plus 2p. Everybody good on that? Equaling, let's put it in there, 2 times 21 minus p. And we're going to pop in the numbers. The number is what? There's only one number, right, to pop in for p. Ooh, pop in for p. I like that. I like that. It's a good phrase there. Put a 5 right here. Put a 5 right here. And put a 5 right there. And let's see where this is going to take us. Remember, this is multiplication. Multiplication, 5 times 5, which is going to give us 25. We've got a minus 3. That's lovely. I've got a 2 times 5 here, which is going to give me what? Looks like 10 more. Let's go ahead and let's say what this is going to be 2 times. How about it? 21 minus 5? I like 16. So we've got everything really wound out from the standpoint. We've almost got one little multiplication to do, but that's going to be really easy. That's going to give us 32 over here on the right. Guess what? We want this to add up, and we got a little subtracting going on too. We want these three numbers to come together to make 32 also. Will they work? Remember, we work left to right at this point with our order of operations. Subtracting. Subtracting, what do we got? 22. Add 10 more to that, and we get 32. Looks like our little friendly equation is checking out. So p equals 5 is a good solution. Goes back in there and substitutes and checks. All right? Are we good? Are we good? Everybody good? All right, and while we're going on this, I want to give a quick shout out. David, Sherry, Jason, Mark, and Margie all participating in Facebook on this. We want to have more of you participating on Facebook. And how do we do that? Well, help me tell you. Let's go ahead and take a look at that while we've got it on my mind. How do you do it? You like us. You love us. You share us. Oh, please share us, because that gets us so much engagement with the community and with your friends, and with your math colleagues, and it just is on and on. It's like infinity and beyond, you know. Buzz Lightyear, what can I say? So like us, love us, and of course, share us. www.facebook.com. We're going to take a /Mathline online. That's where you want to find us on Facebook. And also, you don't have to just play with our problem of the day. You can send us questions there. You can send us problems that you want us to work with for you on that, as well as for our email. But right now, it's all about the calling. Okay, let's hear some phones ringing out there. And that number is 844-686-2378. We want to hear from you. It is toll-free. It does not cost you anything. We are here to help you out working math problems. What better way can you spend a hot, basically stifling almost afternoon outside? Come on inside where the TV is, your monitors, what have you, and let's do some math together, all right? It's a cool place to be inside. So again, that number, 844-686-2378. And while we're waiting for some calls to come through, we've got a little surface area problem here waiting for us. So, we have a caller? We have a caller. Well, we'll wait for the surface area in a little bit, all right? Everybody just hang on. We're going to get back to that surface area. All right, welcome to Mathline, my first caller of the afternoon. And who am I talking with?
Lucius.
It's Lucas. How are you doing?
Good, how are you?
I'm doing well, doing well. Lucas, where are you calling from?
Knoxville, Tennessee.
Knoxville, Tennessee. Good to hear from you. What kind of problem have you got for me today?
It's for slope.
It's a slope. All right, let's hear about the slope.
Find the slope of the line passing through the points -7 and -7 and -3 and 6.
Okay, so let's go back here. You said -7. Repeat your numbers for me just one more time, okay?
-7 and then -7.
Okay.
Great.
Great.
And then for the other one, it's -3 and +6.
-3 and +6, you say?
Yes, sir.
All right. Let's play this thing out, all right? Slope formula. When you're looking for slope, we use the words like, and I'm going to use the letter M because that's what we tend to do for slope. Is that what you're used to seeing? The letter M? Yeah. So what we're going to do, we're going to come up with this little thing called the rise over the run. You've heard those two words, I'm sure.
Yeah.
And when we're playing with that, rise has to do with going vertically. You may be dropping, you may be going up, but you're involving your vertical points, which are the y coordinates. So we're going to put a little y1 minus y2 right there. Is that good for you? And Lucas, you might have heard y2 minus y1, and that's okay also. As long as I stay in the same order, we'll be okay. In fact, I'll do it both ways just to show you that we're going to be okay, all right? And we'll get the same answer, in other words. How about it? And underneath there, we're going to run. So we're going to run horizontally. So that's the x business, all right? So x1 minus x2. So far, so good? Does that make sense?
Yes, sir.
Everything good. All right, great. Now, where we're going to go is from here, we're going to substitute some numbers. Now, I'm going to put a little numbering up here. This is x1, y1. Since it's the first x, it's all arbitrary. And how about this will be x2 and y2 there. And those don't mean squared, folks. That means just the second x and the second y, okay? And x1, y1 simply means first x, first y, all right? And let's put some numbers in there. So we decided y1 is going to be what, -7? Does that sound good?
Yes, sir.
It's also x1, isn't it, too? So we're going to be in a, we couldn't mess up on that one. And we're going to subtract the other y value, and it looks like that's a 6, all right? So we're going to say a -7 minus a 6 in the numerator. Are you with me? Is that good, Lucas?
Yeah.
All right. Down under, I got to worry about these x's. Well, it just so happens I have another -7 to worry about, but this time you've given me a -3. And I've got to make sure I have that subtract sign there because it's subtracting a -3. It's not just saying subtract 3. So you want to be careful on that. And what happens when these two negatives right here that I keep pointing at there to get together, they jam together, it's like saying add the opposite, which is going to be adding a positive. You got it. Very good. So at this point, let's play it out. I basically have a -7. I'm going to add a -6 to it because that's what that is telling me. All right, I'm starting out at -7 and I'm going 6 more to the left. So it looks like I'm at -13. Wow, big number there, right? And underneath that is pretty easy. It's a -7 plus 3. We're in good shape on that. We know the rule for the signs being different is be sure we subtract and keep the sign of the larger absolute value. So in other words, we're going to keep the negative on this also. And we get -4. Are we good so far? Are you with me?
Yeah.
Does that follow? Now, we got one last thing to fix. I got two negatives here. And when we get a ratio or a fraction, however you want to look at it, this simply means division. So we've got a negative divided by a negative, which you know was, what does that do for us, Lucas? It gives us what? Not a negative anymore, but a positive. And I'm looking at 13/4, all right? Now, I said we'd go back and now that you've seen us do it one time, I'm going to let you help me on this one. Let's go back and let's say I did the slope equaling to, let me move that down a little bit, slope equaling to y2 minus y1 this time, over x2 minus x1. Some books use different formulas, but they're basically the same thing. You're looking at rise, you're looking over run, and you're coordinating your points. You see what I'm talking about there?
Yeah.
So let's see how this one is going to fly. This time we're going to start with 6 minus the -7. You see where I'm going there?
Yeah.
So I use y2 minus y1. Under that, I've got a -3, and I'm going to also subtract a -7. Actually, this may look easier because we're not going to worry about a sign change at the end. Because here's going to happen, add the opposite, we get 13. And down here, we're going to add the opposite also, which is going to be plus a positive. And I'm seeing 13/4. We don't have to worry about the two negatives this time. So we still got the same answer either way we do it. Does that work for you?
Yeah.
All right. Hey, well, thank you for calling in on us today, and we appreciate you. And be sure to give us a call next time, okay? We would love to hear from you. All right. Thanks again. And that's it, folks. Very easy. Lucas has shown us how to do it. 844-686-2378. Give us a call. Let us talk, and we'll see what goes on. Speaking of his problem, while I'm at it, let's do one more thing with it, guys. I'm going to throw up a graph paper here because I always think it's nice to be able to see what is this slope talking about when we talk about points, all right? So we got the 2 points here. Let me round back down here again. -7, -7. And also we have -3, 6. Now remember, what are we looking for? We're looking for 13/4. We're looking for a rise of 13 and a run of 4. So let's see how that looks on the picture, all right? And many of our students sometimes don't get this. They see a formula, they work through the formula. So Lucas, here we go. We're going to show you this. We're going to have -7, which is going to take me over here and then down 7. So it looks like we're about right there. I'll make sure I got it right. 1, 2, 3, 4, 5, 6, 7, and down 1, 2, 3, 4, 5, 6, 7. There we are. There's our first point. Our second point says let's go to the left 3 units, 1, 2, 3, and we'll move it up 1, 2, 3, 4, 5, 6 because that's a positive 6, so it's going to go high. And then we're going to, with the help of Curious George here, we're going to connect these little guys here, all right? And that's what slope is. It's how steep is your line. So let's put a line right through there, those 2 points. There we go, how nice. Put those arrows on it because they go on forever and ever, both directions. But let's count the blocks because that's what it's amounting to. How many blocks did we rise going from this point to this point, all right? So let's see, 1, 2, 3, we know it's 7 to here, right? And we got what, 1, 2, 3, 4, 6 more, so we're at 13. Aha, there's that 13 from the rise. Then we go to the right, 1, 2, 3, 4, all right? So that's pretty cool. Now, what would have happened if we started with this being our first point, going down to this one? We would go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this time it's a negative 13, and we're going to the left from that point 4, so it's over negative 4. But guess what? Whether we use 13 over 4 or negative 13 over negative 4, remember that's still, we'll get it right, 13 over, let me try again. 13 over 4. So they do match out either way. I think if you got graph paper, Lucas, it's just as easy to do that. And also you see what's going on there. And by the way, if you say, well, what's the point of having that line? Well, hey, if that's me in a business and I started here and I'm going there, that tells me my business is doing some good things as time moves on, all right? So there's a nice positive slope going on there because it's moving from the lower left to the upper right. And that's a good sign. There's some things you want to go in a negative. For example, maybe you want to figure out the more you brush, teeth that is, I guess you should put that, the less cavities you got. Well, that would be a negative relationship. It's a good one because you hopefully your healthier mouth, less cavities, all right? So as you go to the right, that number of cavities is going to drop off. So that's what it's all about. It's not necessarily bad or good when we talk about a positive slope and a negative slope. We've got to put context. What's our problem? What are we looking at? So there you go. Sometimes people say, will you give us some nice practical examples? There you go. A great example of slope, all right? And again, we had some fun with that. How about it? Speaking of fun, let's do a Hey Mathline. How about it, guys? Can we do that?
Hey Mathline, this is Owen from 4th grade in Indiana. What is the result when 5 4/9 is subtracted from 12?
Wow, Owen, Indiana, Gatlinburg Aquarium. We thank you, Ripley's, for having us up there last summer. And we get some new folks there and have some good times with it. What are the results, or excuse me, what is the result when 5 4/9, that's one nice little clump, is subtracted from 12? So let's play that out. And notice somewhat we've got to make sure we do this right. We're subtracting 5 4/9 from 12. So first of all, even though 5 4/9 was mentioned first, we want to make sure that 12 is on top when we try to do the subtraction here, all right? So again, that's what we're after. Now, how do we deal with something like this? Because basically, dear friends, we have absolutely nothing. So we'll put that nothing over 9. Why not? Why not? 0 divided by 9 is still 0. It's still nothing. So we haven't changed anything yet, but we are going to. We're going to. So let's think about this a little bit. Here I have trying to take 0 from 0 minus 4. It's not going to fly. I can take 0 from 4, but I can't take 4 from 0. So what I've got to do is come over here and say, let's regroup. Let's take one of those units, which is going to drop us down to 11. Okay, I'm going to drop it by 1. And what we're going to do is we're going to take this 11, pull it over here. We're not going to mess with the 5. We're not going to mess with the 4/9. What we are going to do is mess with this 0 because it's the problem. It's our problem child, so to speak here. What do? We're going to take that unit and we're going to spread it. We're going to shred it. We're going to do whatever you want to call it, strip it down, whatever, into 9 equal pieces, all right? Because that's what we want to do here. So we're going to take and make that go 9 over 9. It's renaming it. It's just saying, hey, this is still 11 plus 1, which gives us 12. See that? 9 over 9 becomes a 1. 11 added to that gives us 12. So now we're good to go. We can subtract. So no, here we go. 9 minus 4, that we can do. We get 5. Keep your 9. Don't lose it. Now we got 11 minus the 5, which is going to give us, oh, everybody got that on tip of their tongue right out there. It's going to give you a 6. And my friends, that looks pretty good. Now, you know me. I'm always saying, let's check. You say, well, how do you check on that? We reverse the process. If we take 6 and 5/9 and add 5 and 4/9 together, we should be back at 12. We should get back, well, let's see what we get back to. Everybody looking at it? Let's go. 6 plus 5 gives us 11. The 5 and the 4 come together to make 9. We got 9 over 9, and you know what that means? 1. Add the 1 to the 11, you get back to 12. Nice, nice, nice. So in a problem like this, just simple think about it. Whatever's in that denominator is how you're going to shred and add to that 0 up there. All right, that's the deal. Whatever's there, that's what you're going to be adding when you borrow the unit. If that had been 16, we would have 0 plus 16. Both these were 16s. They aren't, obviously, but they're 9s, so that's what we go with. So it's not always put a 10 like you do when you do decimals, because that's always in a base 10. All right, that's why we always come out with 10s. If we have tenths here, we could actually do that. But since we got 9s or maybe 8s or some other unit in the denominator other than 10, we had to be very aware of what's going on in that numerator, okay? And got to add the right thing over. So there you go. Give us some calls, all right? We're being good here. Luke has been good with us earlier today on slope. Let's see if we can get another call in before we have to go off the air. If not, oh yeah, I promised y'all something about surface area, didn't I? Well, let's take a look at it. Let's see if we can find this surface area of this triangular prism that we've got going on here. And we may, hey, if we get also, again, if we have someone gives us a call, that's fine. We will take a moment with it. Woo, this one looks like maybe a little more than I bit off, bit off a little more than I want to chew here. But well, if we don't finish it, we'll come back to it tomorrow. All right, everybody good on that? Everybody's got it. It gives you a cliffhanger to worry about, right? Okay, I'm seeing a right angle there. And that's basically a right triangle piece going on here. Now, I want you to notice something. It may be hard to see on your screen. Sometimes it's hard on ours. But this is really a broken line here. It's hidden from our view somewhat, all right? And then we've got another little broken, it's a three-dimensional type figure, all right? So, and we have a caller, so we will save this one till tomorrow. I want to get our caller in on the air, okay? So how about it? Welcome to Mathline, and who am I talking with this afternoon?
Nathaniel.
Nathaniel, how are you?
Good, how are you?
Good, I'm doing well also. Where are you calling us from? What city or what county?
Knoxville.
Knoxville, great to have you in Knox County today. And what kind of problem have you got for me? Let's see if we can get it in.
I have a slope.
You got a slope also, all right. Let's see what it is. We'll work through it as quick as we can here.
-7, -4.
Okay. Can I hear?
And 8, and then another 8.
Okay, so let me go back to your first one there. I think I got a little interference. I didn't hear your second digit. What's the Y value with the -7 and what else?
-4.
All right. And then what's your second group here?
8.
And
then another 8.
8 and 8. All right, let's go for it here, all right? You got the formula. You know what it is, right?
Yeah.
All right, so let's do it. Y1 minus Y2 over our X1 minus X2. And I'm going to just go ahead and substitute. Let me go ahead and put this as X1. That'll be Y1, X2, and Y2. Looking good there. So I see a -7 starting us out. No, I don't. What do we see? We see a -4, right? So
Okay.
we've got a -4, and we're going to subtract 8 because we've got to keep our Y's on top, right? Y's
Yes.
rise. Y's rhymes with rise, so we know we're going to rise first, okay? And then we've got this, negative, what is that? -7
Yes, sir.
minus 8, right?
Yes, sir.
All right. And so we did that right? Yep. Let's go for it. I've got a lot of negatives running loose there. That means they're going to stay negative until the very end. All right. I'm seeing adding a -8 there. I see a -12. Does that sound good to you?
Yes, sir.
And what's in our denominator? How about a -15?
Yeah.
I believe so, right? 7 and 8, they'll come together. And we've got all the signs in there, right? Beautiful. Now, we've got a little reducing we can do right there. Let's do it real quickly here. I see 3 is going to divide into both of those. And I also see I've got a negative divided by a negative here, which is going to give me a positive. Are you good with that?
Yes, sir.
So let's divide 3 into that 12. I believe it's going to be, what, 4? And that's going to give me a 5. And that's where I'm going to stick it there, 4/5. Does that sound good?
Yes, sir.
You like it? All right, very good.
Yeah.
And folks, thank you. Thank you both of you guys for calling about slopes today. Other great things we got going. We will be back again live tomorrow, ready to help you guys and ladies also help you through it. And we will see you then.